The chain rule is used in conjunction with everything else we've already done. Okay, so it's kind of buried in there. It is used to take the derivative of a composite function, which remember is a function within a function. Okay, on the last test, I gave you a bonus. I don't know exactly what it was, but it looked something like find the two functions f and g that make up h, and f and g cannot be equal to h. So let's say h was, I forget exactly what it was, but let's say h was something to the fourth power. Okay, now I don't know about you, but I do not want to multiply x squared plus 1 times itself 4 times. Okay, so that's your alternative to find a derivative if you are going to find h prime. But if you can do this, so you have to figure out what two equations, sometimes 3 equations, make up this right here. All right, so what's the inside function? That's your composite inside function, and then we put the g into the f of this. What would be the inside function? Melly?
X squared plus 1.
Yep, and you did this last year. This is very early on. And then f of x, we take what this, and we do what with it?
X to the power.
Right, we take it to the 4th power. Okay? So that is how you make a so when you put x squared plus 1 into x right here, you will get this new function. Okay. So what you have to do, that I consider now I'm going to use the chain rule here, but this is very important because we have to be able to make up and see the composite function. So let's take a look at the chain rule here. This is the one we're going to focus on right now. We'll do this one next class. This is when we're doing tables and charts. We'll use the formula, and this is one we will use most of the time, just because I think it's easier to, for me it's easier to explain, quite honestly. Okay, so what we're doing here is we're going to take the dy dx, which is your derivative of your y with respect to x, and we're going to separate it into 2 different functions. We're going to use u, okay? So we're going to write y right here in terms of u. All right, let me write the original function in terms of u. So that's your first, that would be over here, that would be your inside function. I call that my inside function. Okay. Over here, it's the g of x in our example. Okay. All right. So we're going to write the original function in terms of u, and then we're going to write what u is. Okay. So then you have to find the derivatives of each piece. And again, that might be f, then g, sometimes another one. 2 is pretty common, but occasionally it goes into 3 chains. Okay? But a 2 chain is usually. I was waiting for someone to. Okay. I don't know what I did anymore. Yeah, okay. Y'all ready? Let's try this first example. So the first thing is to figure out what's the inside that we will put into the next function. Now, you've done this piece before. Sometimes it was like difficult. I do remember in pre-cal some of mine, which is the only one I can refer to, having some issues. Don't know if it was you all or not. You remember doing this?
Like that, yeah.
This. Oh, yes. Yeah, yes. Yes, you did this. You totally didn't do the derivatives. Yeah. This is the most important part because the other part's piece of cake because you already know how to find the derivative of those pieces. That's the piece. That's the calculus piece that you're in trouble. This is the piece that are like, I don't know. Okay, so Melody answered the last one. So I'm waiting for someone to find my inside piece that I'm going to write. So y equals sine of 2x becomes y equals something u. In terms of u, that's what we want. Karina.
Okay, so the dot is dy over du over dx. That's supposed to be like.
That's multiplication. Sorry, yes.
Oh, that's multiplication.
Yes, this is multiplication because look what happens. dy du is the derivative of y in terms of u. And du dx is the derivative in term of u in terms of x. And when we do the math, we end up with dy dx, which is what we wanted in the first. We're just dividing it down. Thank you for that. Okay, so in terms of u, who knows what that inside of that? In other words, let's think about what would you do first? I got x. What would you do first? What would you do first? If I know x is pi over 2, what would I do with it? Plug it into what? X. And then what? What's the first operation you would do with pi over 2? Multiply it by 2. So 2. So this is your inside then, right? Okay, so that's going to be my u. Because u then is the first thing we have to do, which is 2x. Then whatever we get there, we take the sine of it. Okay? Now, while you're getting used to these, you think, all right, if I put this guy in here, do I have this? And if the answer is not yes, then you need to do it again. Do it right. Okay? But if you think about the inside is the very first thing you do. I take x, I plug it in, multiply by 2, that's my first operation. The next thing I would do is take that answer and put it into the sine function. Okay, so this is right here, write the original function in terms of u, that's that. Okay, and then write u equals, that's that right here. You're defining your composite function basically. That's all you're doing. Writing your composite function in pieces, I'll say. Not very mathematical, but it works. Okay? So you're defining your composite function. Composite function is a function within a function. All right, now what we got to do, please note this is still y. Now we change to y prime. We're going to take y prime. What's the derivative of sine of u? Let me just rewrite here. And then we're going to multiply. That's this piece. This is this piece right here. Okay? And then we're going to multiply by the derivative of the second piece. That's the easy part. That's the part we're pretty comfortable with. Our test score is average 87. That's pretty darn good. Okay, so here we go. Maria, what's the derivative of sine of u? Cosine u. Okay, and the derivative of 2x, Sarah Coffin? 2.
Wait, I have a question.
Okay.
Why would you not use the product?
Because that's not the chain rule. This is not, that's a good question. This is not a product. That's why we're not using the product rule to find the derivative.
Okay.
Okay? Good question, though. So you can't get confused about, or you can, but you shouldn't. You don't want to get confused about the product rule here because we're using the chain rule. The original thought was this is not a product, so don't use a product rule. I'm just getting all over it. Okay. Getting excited. Okay. Now, you may do up. So put it back. Put it back. What's U? 2x. So there you go. I'm going to put my 2 out front. When I clean it up, this 2 is going to go out front so I don't have to do a dot. And there is my derivative. Big mess of a page, but that's my derivative of sine of 2x. 2 cosine of x. Okay? We need to see it again. Of course, we need to see another example, but we need to go through this example again. You write the composite function. That's going to be your trickiest part. Now, and here's another thing that happens. Once you start the chain rule, you think every derivative now involves the chain rule. How many days have we been doing derivatives? Okay, and we haven't known about the chain rule, so don't think everything is going to be about the chain rule from here on out. It's only those that need it because it's a composite function. Don't make products chain rules. Don't make quotients. Those are all different. Okay, so let's try another one. Oh, this is the, what you call it, rule of thumb. If the function you're differentiating has something besides x plugged into it, use the chain rule. For example, I can do this. If y equals 3x squared, I can do this and then do a quick power rule. Or I could do, instead of that, I could do u squared, where u would be what? 3x. Derivative of u squared is 2u. Derivative of 3x is 3. Put your u back in. Okay? That was way more complex than doing it the old way. Okay? If this was like 19, maybe you'd want to consider doing the chain rule instead of multiplying 3x and itself 19 times. Okay? Let's talk about this one. We know the derivative of tangent, but we don't know the derivative of tangent squared. Now we have two choices. We can do the product rule here, because that's now changed to a product. Tangent x, prime, tangent x, etc. I'm not going to go through it. Or we could use the chain rule. Okay, how would that look for the chain rule? When I multiply tangent times tangent, I still get tangent squared. I can't fix that. So what would tangent squared be written as in terms of u? I don't know why I just rewrote that. The first thing I'm going to do, write it in terms of u. What's the first thing I'm going to do with that inside function?
So it'd be like u squared and then u.
Very good. Tangent x goes into u. We have u squared. Okay, and then we do derivative of u squared and derivative of tangent of x. We'll finish it here using the chain rule. Again, this is going to be the part that you're probably going to have the most pause about. Okay? Now, what I wanted to say is this typically is going to be written like this. Okay? So be aware this means that. Okay, Rachel?
For inside function, you just mean the part inside difference. It won't always be
Correct. But yes, in this case, it definitely is. It's the first function. The thing you do first, that's the inside function. And remember, inside means when you're doing composite functions, you're doing f composite g. That means f of g. The g is your inside function. That's how we described the composite function from the very beginning. Okay, still working on my prime. All right. Tabitha, what's the derivative of u squared? Good job. And Olivia, what's the derivative of tangent of x? Good job. Okay. You made up u, so let's put it back. That makes u be tangent of x. Secant square root of x. I'm done. Okay. Now, if you did it over here, you would get the same thing. In fact, you have done this before. Secant squared, tangent, secant squared. There you got two of the same things, which is what we had right here. These are the same. Okay? Sometimes you'd rather do the product rule because that's what you think about doing it. You're not really sitting, most of us are not really sitting there, I can do this or I can do this. We just do what we think about doing at the time. Yes, Kayla? Yeah, you got to figure out what the composite is. In this case, you got to figure out this was tangent of x. So what's the first thing you do if you had y, Bailey? Or excuse me, x. What's the first thing you do? Say x is pi over 4. First thing I'm going to do, plug in, and what's the first operation? There's no multiplication. I'm going to plug in y equals tangent of pi over 4. Okay, so what am I going to do first? Find the tangent of y over 4. That's your inside function, and then you're going to do what? Once you have the tangent of pi over 4, you're going to square it. Okay? So the first thing you do is your inside. And that will get easier, but that's going to give you the most pause at the beginning because it's just a little bit awkward for some of us. I don't know why. I don't know how to fix it, but this is the only way I can explain it is what are you doing first, plugging in, and then taking the tangent that you're inside. Then you're taking that and squaring that you're outside. Okay? So, let's try the other one. Okay. F of x is tangent of 5x squared. We're looking for the derivative, which is f prime. All right. So, f of x, I'm just going to rewrite this so it's all in a line, is, what are my two functions? What are my two functions? You got the last one, you got the first one. We're trying to get along the other 13. Tabitha. Tangent of u. Okay, and then u equals what again? That seems reasonable. If we put this in here, we will have that. Good job, Tabitha. Okay. All right, very good. Okay, so that's still f of x. Now we're ready for f prime of x, which is, oopsie, derivative of what Tabitha just said, times the derivative of the other thing. It is not a product, it is a chain rule, and that's how we do the chain rule. We figure out the chain, which is the composite functions, and then we take the derivative of each part. All right. Chelsea, what's the derivative of tangent of u?
Secant squared u.
Good. And the derivative of 5x squared, Kelsey?
10x.
10x. Good. Okay, what do we got to do left? Yet, Sarah Whalem, besides clean it up. They have a weird variable.
Can you plug in 5x?
Yes, ma'am. Plug in 5x squared for u. Okay? If you want, probably should, just because of, you can eliminate the dot. There's your simplified version there. Okay? is also, putting this out front also eliminates, some of you will like to do this, and then you multiplied by this, and you made this. That's not true. This equals this, which is different. So be careful. That's why I put it out front, if I can, and then there's no confusion about, wait, am I multiplying this by this? You're taking the secant squared of whatever this is times 10x, so put it out front, okay? All right, there is possibly, any questions on this? Do I need to go over it again? All right, there's possibly, not sure why that's hidden over here. I don't know that we're going to get into 3, but there's a 3 chain. We'll grab that when we need it. Okay, here we go. Get it? U is, get it? All right, by the derivative of y equals sine to the 5th of x. Now, please keep in mind, this is how we write sine x to the 5th. Okay? That is not, you know, rocket science. That is just how it's written. So you have to understand that is not anything special. Okay. Who wants to give me my... So I'm going to write it like that, and now I'm going to write in terms of u. So we got Maria going here. We had Melanie give us an answer. We had Tabitha. All right. 12 other people. Or excuse me, 11. Chelsea.
Would y equal u to the 5th and u equals sine x?
Excellent. Good job. Okay. So it's kind of working what Rachel was saying. What's in parentheses is the inside. Sometimes that's helpful. Sometimes the parentheses aren't there, but you can put them there, I suppose. Okay. I prime equals u to the 5th prime times sine of x prime. Eventually, you won't have to write that statement out. You just jump into the derivatives from the u statements there. All right. Annalisa, what's the derivative of u to the 5th? Very good. And let's see, Sarah, what's the derivative of sine of x? Good job. All right, what do we got to do yet, Karina? Nothing? I got a u.
Oh, we have a u.
I have a u.
So,
Okay, remember u is sine of x, so we put it back in here. Remember how we write it? We do it like this. Okay? And then cosine of x also is there. Okay? No. Probably not. Remember that is that. No, the parentheses aren't really necessary if you... Okay. All right, very good. All right, let's try this one by yourself. I'm gonna pause this temporarily. Yeah. No, I do not. I do not want you to multiply it out. Yes.
Wait, you don't want
I do not. Just because. Yeah, if it's factored, if it's all factored, leave it factored. Combine some factors if you want. Anyway, but don't multiply that out. That'll make you crazy. All right. So everybody has u cubed for u equals 9x squared plus 6x. Now we're ready for y prime. Please note this is still y. We're just putting y in terms of u. Make sure your notation makes sense. Okay, derivative of u cubed is 3u squared. Derivative of 9x squared is 18x plus 6. Did I lose anybody? All right. 3u squared. Put u back in. Okay, I'm really, oopsie, good with that. There's nothing wrong with that. It's all factored. It's all good. Now, if there was a little piece factor plus another little piece factor, you'd have to do the multiplication. In this case, it's all good. You know, if you want to throw the 3 in there, it would be fine, but it's not necessary. So usually, if it's all factored, it's perfect, because then we can do something with it later. After we're done with the methods, we're going to do some applications, and this would be easy to solve equals 0, because it's all factored already. Okay? This is probably the thing that most people forget. As you can see, I just did it almost. U gets in there. We're concentrating on U, but don't forget it's U squared sitting there. Okay? Any questions on that one? All right, let's see. Okay. Do you remember e to the x, the derivative of e to the x? It's e to the x. Okay. Because it's e, it's special. All right. If a is any other constant, 5, 2, 9, 14, then your derivative of a to the x is a to the x ln a. Okay? So this is another one that you add to your list with the trigs. You should have 15 now that you know, okay, including this. So, for example, 5 to the x derivative is 5 to the x times ln of 5. A is 5 here. A is a constant except for e. If you do e like that, look. E to the x, ln e. What's ln e? So it does work, but you just don't want to say the derivative of 5 to the x is 5 to the x. It's not. It's 5 to the x times ln 5. Okay? So what's the derivative of 2 to the x? 2 to the x, ln 2. Okay? ln 2 is some goofy number. You know, it's e to some power equal 2, but we don't care. Just leave it alone. It's like another constant. ln 2 is that ugly number right there. We're not putting that in. We're just going to leave it alone. Exact is better. Okay. So let's use that derivative with this chain rule. All right. So we got to figure out the chain. dy dx is the derivative. Y equals 2 sine of pi x. All right. We'll try to figure out the composite function first. All right. The composite. Rena? 2 to the u, you mean?
Yes.
Okay. Where u is. Oops. You're good. Guess what we have? A chain of 3. It's the first time. We don't know how to take the derivative to sine pi x. So we're going to call this v, where v is 2x. Okay? So we put 2x in here. We got sine of 2x. We put sine of 2 pi x. Sorry. I don't know why I said 2x. So that's what I mean. Pi x. Okay? A good start, Karina. You had it. All right. Now, that's why. So now we're interested in y prime, which is 2 to the u derivative times sine of v derivative times pi x derivative. Remember, pi is a constant when you get to that piece. All right. This is the new derivative. We just got this page there. Talking, what's the derivative of 2 to the u? No.
Oh.
2 to the u. There you go. Now, I stopped her But I probably should have let her finish because that's a very common mistake. She wanted to use the power rule, didn't you? Yes. Okay. You only get to use the power rule when the base is your there we go, thank you. Power rule, x to the 5. Your base is your variable. You can't use it when your base is your constant. That's a different derivative. Okay. All right, what's the derivative of sine of v, Natalie? Cosine b. Good job. And the derivative of pi x? Pi. Good job. It's just like a 2 sitting there. 2x, the derivative would be 2. Okay, now we got to start putting our u's and our v's back in. Okay, so that's when you pay attention to what we wrote up there. U is sine of v, ln 2 cosine, don't really, I'm going to put a dot. Cosine of v, v is pi x times pi. Okay, I got one more substitution because I still got a v. So I'm going to put my pi out front eventually. 2 sine of v is 2x. I'm going to put my pi in here. Pi. Sorry, why do I keep saying 2? Thank you, thank you, thank you. Yes, okay, sine of pi x. How's that? ln of 2 is just a constant hanging out. Pi, that's why I was going to put pi first. So I have to put 3 dots. Okay, and cosine of pi x. Okay.
Where the pi came from.
The derivative of pi x. That's the power rule. We pull. We hold on to the constant.
Yeah, you just said you.
Yep. Yep. No, the order doesn't matter at all. As long as you got everything, just be careful that this pi doesn't get stuck with pi square over here. That pi has nothing to do with this guy right here. ln2 is just a constant, so that should be somewhere up front. Okay, but the order, good point, Karina, does not matter. Question, Melanie? I just asked you. Okay, it's just ugly, but remember it was ugly to start with, so it's going to have an ugly derivative. Yes.
There's like, is it, like, so, like, I guess it's not necessary to have the same, like, because you have, like, 2 to the sine pi x is an exponential form, and then you have a log.
You couldn't put them together because they're not bases,
Okay.
and they're multiplied anyway. This is a base e, so
Okay. But it doesn't matter that, like, one's an exponential
No.
form and one's a log form.
nope. Good question though.
Can I get a drink?
Yeah. All right. We're not going to do the charts and tables at the end, but we got some more examples. How about you do those, and then we'll regroup here. Oh, I want to freeze. Ah. Come on. It's pretty interesting. Well, I think I might need a new battery. The freeze button isn't very good either. Okay.
You do it in a star system, and there's like a spot in the middle that's just glory. Just like in the very middle.
Okay, so tangent U. If you're not needing to write this step out, then just jump right to here. No. The less you can write, the less mistake you'll have going on here. Secant square, I'm going to put my 3 out front. Eventually, just so I can do less dots. Okay? Did anybody not get that? I saw you like this step.
Why do you have lines?
Where do I have what? Where?
The 3 I don't
Oh, yeah. That was my U?
Yeah.
Okay. Who started on 2? All right, what'd you start with? The chain rule?
Yeah.
So how'd you do the chain rule? Sorry.
R equals,
Okay, that works. Anybody do it differently? What'd you start with?
I think I did it wrong, but, can you do tan to theta, and then make secant to theta?
No. Because you don't know how to do tangent. This is good, and it makes sense. Okay, because if we put a 2 theta in here and in here, we would have that thing. Now, that R, I should say. When we do R prime, I guess this is what I was looking for. How are we going to find the derivative of tangent using product rule? Okay. So again, yeah, so now we're starting to mix them a little bit, which gets kind of like, we can't just think about the chain rule. We got to think, okay, wait, this could be a product as well. So I'm just going to write it out. Tangent U, prime, secant U. What's the rest of it, Bailey? The product rule? Okay. And since nobody really thought of that other method, I mean, that can go there. Times, now be careful. This whole thing needs to be multiplied by what? The derivative of, okay, 2 theta. Theta is your variable this time. I have a dot in there. Okay, so watch the parentheses. All right, what's the derivative of tangent of U? Melanie?
Changing, oh, sorry, secant.
Okay. Secant U, tangent U, and the derivative of secant U? Rachel?
Is it secant U to?
It is. Good job. And the derivative of 2 theta? Karina? 2. Okay. Now it's a mess. First thing I'm going to do is put my 2 out front and then my parentheses, and that way. Okay, so what do I got here? Secant cubed plus, what's that? Cleaned up. Tangent squared U, secant U. I cleaned it up, but I should have done, I also need to do what? Put the U back in. So secant squared 2 theta, tangent squared 2 theta, secant 2 theta. Okay, 2 is multiplied by the whole thing. Okay? Do what? Oh gosh, okay. It's not fine. I said cubed is fine. Trying to do it. Okay.
So in that case, you have to have the parentheses instead of multiplying
If you didn't have the parentheses and you just had the 2 sitting out front, what would the 2 get multiplied by? Just the first part. And yeah, that's totally different. But yes, you do need the parentheses. Parentheses get us in all kinds of trouble. Okay. This 4 is a constant. So when we do that U piece, that 4 just is going to hang around for a little bit. So we want to grab it. All right, what's our U here? Keep in mind, this is to what power? 1/2. That might help. Yes.
Y equals 4 squared U.
So U to the 1/2? Yes. Okay. Or U is
Secant X plus.
very good. Okay. Now that 4u to the 1/2, if you put u in here, you will get this, which is the same as that. So I'm kind of rushing because we're running out of time, but it should be good. So what's the derivative of 4u to the 1/2 there, Stuart?
2u.
Very good. Again, that 2u to the negative 1/2 gets multiplied by secant x plus tangent x prime, which I'm not writing anymore, if you noticed. But if you need to write it, write it. I just did it, and had Sarah did it. Okay. Give me a little room here, there. Okay. There, now I'm writing it. Okay, what's the derivative of secant x plus tangent x, Sarah Whalen? Right here. No, there's no product. Product means multiplication, that's addition. Derivative of secant, which is? Okay. Plus derivative of tangent. Nice. Okay. Secant squared of x. I know you said secant x squared, but I knew what you meant. Okay. And then the 2, the u gets replaced. You can leave it, usually. Let's factor this, because it may be something going on with this one, since it's so ugly. Well, how could we factor secant tangent plus secant squared? Pull secant out. Good job. And what's left? Tangent plus secant. Okay, now you see why I wanted to do that. This can be combined with this. We have one of them, we have negative half of one. How many do we have, really? Sorry. Is everybody caught up? So there. I got the 2, I got 1. If I got x to the negative 1/2 and x to the first, I got what power? 1/2. And then secant x. Basically, put that out front. Let's print this. So that's your final answer. Okay. So we got change a little mixed up in everything. Thank you.